Hello everyone, my name is Nursultan and today I will show and tell you about computer networks design poster. Firstly, I want to answer the question, what is computer networks? Computer networks are like digital highway that connect different devices, enabling seamless communication, information sharing and collaboration. These networks like various devices such as computers, phones and tablets, forming an interconnected web of technology. To make this possible, networks rely on specialized network infrastructure, including hardware like routers and cables, as well as software protocols. By leveraging computer networks, individuals and organizations can stay connected, share ideas, and collaborate efficiently regardless of distance. The next is nodes. A node is any physical device within a network of other tools that's able to send, receive, or forward information. A personal computer is the most common node. It's called the computer node or internet node. Modems, switches, hubs, bridges, servers, and printers are also nodes, as are other devices that connect over Wi-Fi or Ethernet. For example, here, a network connecting one computer, phone, laptop, server, and hubs. Totally 5 nodes. Nodes within a computer network must have some form of identification, like an IP address or MAC address. We will talk about later. For other networks, device to recognize them. A node without this information or one that's offline no longer function as a node. The next is OSI and the TCP IP models. The Open System Interconnections models defines a networking framework to implement protocols in layers within control passed from one layer to the next. It's primarily used today as a teaching tool. OSI has 7 layers and the TCP IP has 4 layers. The OSI models is a logical and conceptual models that defines network communication used by system open to interconnection and communication with other systems. On the other hand, TCP IP helps you to determine how a specific computer should be connected to the internet and how you can be transmitted between them. The lower layers deal with electric signals, chunks of binary data, and the routing of this data across networking. Higher levels cover network requests and response, representation of idea, and network protocols as seen from a user's point of view. The next is protocols. A network protocols is a set of established rules that specify how to format, send, and receive data so that computer network endpoints, including computers, servers, routers, and virtual machines, can communicate despite difference in their underlying infrastructure design or standards. Without network protocols, computers and other devices wouldn't know how to engage with each other. As a result, except for specialty networks built around a specific architecture, few networks would be able to function, and the internet as we know it wouldn't exist. Virtually all networks and users rely on network protocols for connectivity. There you can see protocols like DNS, HTTP, IP, and FTP. DNS, or Domain Name System, greatly powers of our internet experience by translating human readable domain names like www.example.com into numerical IP address like 192.0.201, enabling us to access websites, send emails, and use various online services seamlessly. The next is IP address. IP Internet Protocol. IP silently guides data packets across the internet, allowing devices to communicate with each other. Whether we're browsing the web, streaming videos, or sending messages, IP ensures our data reaches its destination accurately and efficiently. The next is physical layer and the connections. At layer 1, the physical layer of OSI model is responsible for the ultimate transmission of digital data bits from the physical layer of the sending source device of the network communications media of the physical layer of the receiving destination device. Examples of layer 1 technologies include Ethernet cables and hubs. Also, hubs and other repeaters are standard network devices that function at the physical layer as a cable connectors. At the physical layer, data is transmitted using the type of signaling supported of the physical medium: copper cable, fiber optic cable, wireless network. The next is data link layer. When obtaining data from the physical layer, the data link layer checks for physical transmission errors and packages bits into data frames. The data link layer also manages physical addressing schemes such as MAC address for Ethernet networks, controlling access of networks device to the physical medium. Because the data link layer is the most complex layer in the OSI model, it is often divided into two parts: the media access control sublayer, or MAC address, and MAC control, and the logical link control sublayer. The next is network layer. The network layer adds the concepts of routing above the data link layer. When data arrives at the network layer, the source and the destination addresses containing device contained inside each frame are examined to determine if the data has reached its final destination. If the data has reached the final destination, layer 3 formats the data into packets delivered to the transport layer. Otherwise, the network layer updates the destination address and pushes the frame down to the lower layers. To support routing, the network layer maintains logical addresses such as IP address for device on the network. The network layer also manages the mapping between the logical address and the physical address. In IPv4 networking, this mapping is accomplished through the addresses resolution protocol. IPv6 uses network discovery protocols. And also you can see here routing and the de-encapsulation. The next is IPv4 and IPv6 addressing. An IP address provides an identity to a network device on the internet, similar to a home or business address that supplies a specific physical location with an identifiable address. Devices on a network differentially from one another through IP addresses. If you send a package to a friend in other country, you have to know the exact destination. This same general process is used to send data over the internet. However, instead of using a physical mailing address, the computer uses DNS servers to look up a host name to find its IP address. For example, when you enter the website URL such as www.example.com into a web browser, your request to load that page is sent to DNS servers that look up the hostname of example.com to find its corresponding IP address. Without the IP address, the computer has no clue what is it that you are after. IPv versions. There are two versions of IP Internet protocols, version IPv4 and the Ethernet protocol version IPv6. The format is the older version, while IPv6 is the upgraded IP version. One reason IPv6 is displaying IPv4 is that it provides a larger number of IP addresses than IPv4 when multiple devices on the same networks are connected to the internet. It's important that there is a unique address available for each device. The next is transport layer. The transport layer delivers data across network connection. TCP, Transmission Control Protocol, and the UDP, User Datagram Protocol, are the most common examples of transport layer for network protocols. Different transport protocols may support a range of optional capabilities, including error discovery, flow control, support for retransmission. The next is application layers. There you can see three layers. So the first is session layers. The session layers manages the sequence and the flow of events that initiate and tear down network connections. At layer 5, it's built to support multiple types of connections that can be created dynamically and run over individual networks. The next is presentation layer. The presentation layer has a simplest function of any piece of OSI model. At layer 6, it handles syntax processing of message data such as format conversion and the encryption, decryption needed to support the application layer above its application layer. The next is application layer. The application layer supplies network services to end-user applications. Network services are protocols that work with user data. For example, in a web browser application, the application layer protocols HTTP package the data needed to send and receive web page content. This layer 7 provides data to the presentation layer. The last one is network security. Network security is the protection of the underlying networking infrastructure from unauthorized access, misuse, or theft. It involves creating and secure infrastructure for devices, applications, users, and the application to work in a secure manner. So that's all for today. I think you understand something about computer networks. Thank you for your attention. Bye bye.